We're going to investigate the reaction of some different metals with two different acids. We're going to be looking at hydrochloric acid and sulphuric acid. So I've measured out, using a measuring cylinder, 5 centimetres cubed of hydrochloric acid and put that into these four test tubes here. I then measured out 5 centimetres cubed of sulphuric acid and put that in these 4 test tubes here. And as you can see, just by looking at the two acids, you won't be able to tell them apart. They're both clear, colourless liquids. The metals that we're going to be using in today's investigation are iron, so I've got two iron nails here, copper, I've got some pieces of copper, zinc and magnesium. We're going to observe what happens when we add them into each of the acids. We're going to see if there's a difference in the reactivity with the two acids, and we're going to compare the reactivity of the 4 metals. Okay, so the first one I'm going to start off with is iron. So I'm just going to place my iron nail into the first test tube with hydrochloric acid. Okay, and there's no obvious reaction to start with, but we'll come back in a moment and have a little look to see whether or not we can see it reacting. I'm going to do the same with the sulphuric acid. So I've put that in the sulphuric acid there, and we'll come back and have a look to see whether that is reacting in a moment. The next one is copper, so I'm just going to place a piece of copper into the hydrochloric acid. See there, no sign of a reaction yet. And I'm going to place a piece of copper into the sulphuric acid. Again, no obvious sign of a reaction yet. Now let's move on to our zinc. So zinc, we've got a shiny silvery coloured metal here. Let's move on to the third test tube. Okay, so I place the zinc into my hydrochloric acid there. And I'll place the zinc into the sulphuric acid. And lastly, the magnesium. So magnesium comes in these ribbons or strips. So I'm going to place a strip of magnesium into the hydrochloric acid. And with the hydrochloric acid, we can see we've started to get some bubbling. And then I'm going to place a strip of metal into the sulphuric acid. And again, we've got some bubbling. Okay. So that tells us a little bit about the reactivity so far. So we definitely know that the magnesium is the most reactive. And look, it is reacting in a very similar way with both acids. But actually it's bubbling, it looks like it's bubbling more vigorously with the hydrochloric acid compared to the sulphuric acid. Okay. The next thing we're going to do is to test what gas that is being made. To do that, I'm going to use a lit splint. I'll light my match and light the splint. And I'm just going to put my thumb over the test tube just to collect the gas, allow the gas to build up. And I'm going to place the lit splint inside the test tube and see what happens. And so we get the squeaky pop that tells us hydrogen gas is being made. And we're going to test the other magnesium as well just to check that we are making the same gas. So light my splint, collect the hydrogen gas, if it is hydrogen gas that's being made. Just allow that to build up. And let's test it. Again, the squeaky pop tells us that hydrogen gas is being made. So when magnesium reacts with hydrochloric acid and sulphuric acid, both of them make hydrogen gas. So let's have a look at the other metals and see whether we've got a reaction there. So first of all, let's look back at the iron. So if we look carefully at the iron now, we can see some very small bubbles just on the surface of the iron nail. So that tells us it's very, very slowly starting to react. Now I could do the squeaky pop test with the iron as well, but the amount of gas that is being produced by the iron is very small, so it's unlikely we would get a squeaky pop. And let's have a look at the sulphuric acid. Again, on the surface of the iron nail, we've started to get some small bubbles that are appearing. Now let's look at the copper. When we look at the copper, however, there are no bubbles whatsoever being formed. So the copper is not reacting with the hydrochloric acid at all. Let's look at the sulphuric acid. Again, no bubbles on the copper. No reaction is taking place with the sulphuric acid. So copper does not react with our two acids. Finally, let's look at the zinc. Again, on close inspection with the zinc, we can see that we've got some bubbles on the surface of the liquid. Let's have a look at the sulphuric acid. Again, we've got some bubbles. So we know that the copper does not react at all, so that tells us that it is the least reactive of our four metals. So now we need to decide which is more reactive, the zinc and the iron. And if we compare these two, there are considerably more bubbles on the surface of the zinc compared to the surface of the iron. So that tells us that the zinc is more reactive compared to the iron. Now, in order to make this a fair test, ideally we should have exactly the same mass of metals, exactly the same surface area of the metals, which involves having the same size and shape of strip, which was hard to control in this experiment. Other control variables have been the volume of the acid that I've used, 5 centimetres cubed each time, and also the concentration of the acid was the same for each experiment. So there we go, we have the reactivity of our four metals, magnesium being the most reactive, copper being the least reactive, and we know that we could produce hydrogen gas when our metals react with both hydrochloric acid and sulphuric acid.